Okay, so as mentioned in the previous video, we can deduce the number of roots. How many roots? By calculating the value of the discriminant, or the other way around. We can use the discriminant to decide the number of roots. So both ways are possible. So based on the summary, in this example, we are going to determine the nature of roots by calculating the value of the discriminant. So let's recap. Nature of roots. So there are a few natures. So if you got two roots, the nature will be real and distinct. So if you have one root, the nature will be real and equal. If you got no roots, then it's just no roots. Okay, so there will be some condition to correspond to the nature. So for two roots, the discriminant is usually a positive function or a positive value. For equal roots, the discriminant is equal to 0. For no roots, the discriminant is going to be negative. So this is the main summary. So we're going to explore the idea in this few questions. So if you're going to calculate the value of the discriminant, obviously you need your ABC to be correct. So I will calculate my ABC. So in this case, I get a negative value. So the explanation will be something like this. So since you are getting a negative discriminant, then there should be no roots. So there are no roots. That means if you solve the equation, you will have no answers. Okay, so let's try the next one. So get your ABC so that you can calculate the value of the discriminant. So punch your calculator. In this case, you will get a 0. So this time around, the value of 0 discriminant imply that this equation will have one root. So the nature will be real and equal roots. So we try to tell from the value of the discriminant. Okay, so you realize the discriminant doesn't have any algebra, unknown algebra. We're getting some precise values first. Okay, so second one, let's try again. Okay, make sure your ABC are correct. Okay, let's try to calculate the discriminant. So in this case, my discriminant is a positive value. So since my discriminant is a positive value, okay, that means, right, the equation should have two roots. So the nature that we're looking for will be real and distinct roots. So that's how we use the value of the discriminant to decide the root. Okay, as mentioned in the theory, it can be the other way around as well. So in the subsequent example, we are doing it in the other way around. So in the subsequent example, we know the nature of the roots. So we are told the nature of the roots. So I'm going the opposite way. So right now, because it has real and equal roots, okay, what do you expect from the discriminant? So you go in the opposite idea. So with the idea that the equation has real and equal roots, I'm expecting the discriminant to be equal to 0. So I need to execute the discriminant so as to solve the question to find a possible P. So, so what I will do is usually I will do my expansion first. Okay, getting the ABC can be quite tricky sometimes. So that's why some of you will get the wrong ABC. So strictly, it must be the coefficient of x squared. Strictly, it must be the coefficient of x. C has to be the constant. So in this question, okay, so you can do an explanation. Since the equation has real and equal roots, so they are telling us the nature of the roots directly. So it leads us back to the condition. So the condition for equal roots will be equal to 0. And then you add in your ABC. As you add in the ABC, you should be able to solve. Okay, you should be able to solve for it. So in example 3, we use the value of the discriminant to decide the nature of the roots. So in example 4, we are using it the other way around. From the nature of the roots, we link back to the condition of the discriminant. So it's actually a very repetitive thing. Okay, so in the next question, we got roots that are real and distinct. So this is the nature of the roots, real and distinct. So being real and distinct, it leads us to the condition of the discriminant being positive. So I will be executing this condition because the roots are real and distinct. Okay, before I can execute, okay, I need to be able to explore my ABC. Okay, this is the part where a lot of people might not get the correct ABC. So in this question, A is A. In this question, B is a minus 4A. C is 4A minus B. So there shouldn't be any X in C because C is a constant. Okay, so in your ABC, right, there shouldn't be X. So some students, right, will accidentally input X into the value of ABC. So that shouldn't be the case. So make sure your ABC are correct, and then we will do an explanation. So we are told about the nature of the roots. So it leads us back to the condition. And we insert our ABC. After you insert your ABC, it looks more like an algebra. So this part cancel. I'm left with 20A. 0 divided by 20. I'm left with A greater than 0. Okay, so it's actually very repetitive, the condition. So once you decide the condition, you get the ABC from the equation to execute the condition. Okay, so if you look at the next few examples, it's also very repetitive. So for example 6, the roots are not real, unreal roots. So this is the nature of the roots. So it is indirectly telling us that the discriminant is actually negative. So again, okay, I'm going to explore the equation first. So explore the equation properly so that you can compare your ABC. So if you realize you always have issue getting the correct ABC, I suggest you do such a comparison. Otherwise, when you get your ABC wrong, you will not be able to execute the condition correctly. So once you get the ABC, you do the explanation. So since the equation has no roots, so it is implying that the discriminant is negative. So you insert in your ABC. So like I mentioned, when you insert your ABC, it looks very complex because you need to do the algebra expansion here first. In fact, you got to make sure that you got no careless mistake. And this part is cancelled off. You end up with 12p plus 4p less than 0. So that's how you get the answer. So if they tell you the nature of the roots, you link it back to the condition of the discriminant. And then make sure you extracted out your ABC correctly and execute the condition of the discriminant. Okay, so same thing. If you look at example 7 can be a little bit more tricky. So when the question says real roots, okay, there are two situations. It can be real and distinct, which means the discriminant is positive, or it can be real and equal, which means that the discriminant is equal to 0. So that is the implication of real roots. So in actual fact, you will combine both conditions. So the implication of real root can be these two cases. So I will be combining the two conditions to be greater or equal to 0. So that is the reason why for real roots, you actually have an equal to 0, because it implies the two situations. Okay, so again, let's explore the equation first. The equation looks very huge, but if you look real carefully, you realize that the whole chunk here, this whole chunk doesn't have your x at all. So in this case, my ax squared, a is 1. Okay, you compare the x here, b is 2k. So remember the constant c doesn't have x. So the expression k squared minus 5k plus 7 is not x. So it's classified under the constant. So from here, I will do an explanation again. Since the equation has real roots, so the nature of the roots indicate the condition of the discriminant. You insert your ABC to execute the condition. So most of the time when you insert in your ABC, you will find it seems like there's a lot of algebra. Okay, it's true there's a lot of algebra, and the algebra will get quite extensive later on. So this part cancel off. So that's how I get my answer. Okay, so if they tell you the nature of the roots, you link it back to the condition of the discriminant. Subsequently, like example 3, we use the value of the discriminant to tell about the nature of the roots, or it can be the other way around, like the subsequent example 4 to 7. We know the nature of the roots. From the nature of the roots, we can tell the condition of the discriminant. So these are the basic idea. It can be quite repetitive. Same like the condition, and then you execute your ABC. So the ABC in every equation can be different. So the important thing is you get the correct ABC. You might get the condition correct, but then if your ABC is wrong, then you couldn't execute the condition correctly. Okay, but for such type of question, if you execute the condition wrongly, so if you, for example, in this case, it's real and equal roots, the discriminant is equal to 0. If you accidentally chose the discriminant to be less than 0, the whole question will get you 0 marks. So if your condition of the discriminant is not correct, the whole question is a 0 mark, no matter how much working you do, because you have not gotten the correct thinking. So that is the important part behind this type of question. Okay, but like I say, it's very repetitive. Get the condition, insert the ABC.